Hey, hello and welcome to today's GFG problem that you're uploading well. So let's see today's problem anagram. Okay, so what the problem is saying is we'll be given two strings consisting of lowercase characters. The task is to check whether two given strings are an anagram of each other. Okay, so what the problem is saying is, for example, let's say there are two strings act, right, and tack. So we want to find out whether the given strings, right? The given strings are anagram or not. So what is anagram? So anagram is nothing but like all the characters of string one are part of like string two. Okay. For example, all the characters, the frequency of all the characters is same as the frequency of all the characters in string two. For example, here A has come one time, right? C has come one time and T has come one time. Here also, if you see, T has come one time, A has come one time, and C has come one time. Okay, so that's what I said. So the characters and their frequencies, all they match. They should match basically in both the strings. If it is a case, then we have to return true. Else we have to return false. Okay, so this is the case. Now, how can we solve the problem? Okay, how can we solve the problem? So what we are going to do is we are going to use, for example, we are going to have an array of size 26 because the number of alphabets in yeah, right, the number of alphabets is 26 basically. Okay, so 0 1 2 3 4 5 6 7 8 9 10 11 12 13, let me write 14 15 16 17 18 19 20 21 22. Okay, this has become 23 24 25 and 26. Not a very let me also create the array. It will take some time. 13 14 15 16 18 19 20 21 22 23 24 25 and 26. Okay, so we will take an array of size 26. Okay, we'll take a size of array of 26 because of the size of alphabets, right? Okay, now what we are going to do is we are going to use the ASCII property to store the characters. So how? For example, the character is A, right? If the character is A, so we are going to deduct the ASCII of A basically. Okay. So how? For example, so what is ASCII of A? It is 97, right? And ASCII of A again, it is 97. So it becomes 0. So A will go on 0th position. Okay. For example, if the character is B, right? If the character is B and if I each time whatever is the character, I'm going to deduct the ASCII of A basically. So the ASCII of B is what? 98, right? And ASCII of A is 97. So it 1 becomes 1, right? So B will go to one position number 1. Similarly, whatever is the ASCII of G minus ASCII of A, we are going to do that, right? G minus A. Okay. So whatever the character comes, for example, 8. Okay. Okay, so it will the character will go over there. So let's, for simplicity purpose, we won't take this example. Let's take this example. Okay, act and tack. Okay, tack. Okay, or maybe let's take A. Sorry, not this one. Let's take A B C and B C A, for example. Okay, B C A for simplicity purpose, because you'll be able to keep the track of the ASCII characters here. Okay, so let's start. So for example, if this is S1, right? Sorry. If this is S1 and this is S2, okay? Okay, so now the first character is A, right? So what we're going to do? So again, as I said, right? Uh, Deduct the ASCII of A here. So it is going to be 0, right? So we'll increment the frequency here, A. Okay, then we'll go to the next character B, right? Again, I've already explained this. So B minus ASCII of A will give us what? 1. 98 minus 97, it will give us 1. So we'll increment the frequency here. Then we have character C, right? We have character C. So again, ASCII of it is 99 minus A, right? 97, which we get 2, right? So we are going to increment the frequency of here. Okay. So we are done processing S1. Now we are going to iterate through S2. And so what we're going to do here? So for example, now the first character we got B. So what this becomes, the position comes, the index comes as 1. So we are going to decrement the frequency. -1 we are going to do. So we got 0. Then C, for C, the same thing again. The position which comes is 2, right? So we're going to decrement the frequency. Okay. And then we're going to come to this character again. What it comes, the position comes as 0, so we're going to decrement the frequency. Okay, so we are done iterating s2 here. Now what we're going to do, we're going to iterate through this array, and wherever we don't find 0 frequency, we are going to return there. Okay, we're going to return there. For example, okay, so in this case, all the when we create the array, in generally they are 0 only rest, right? So if all the positions are 0, right, we are going to return true. That means the frequency exactly matched the frequency of characters exactly match in both the strings. Okay, so wherever there is non-zero value, be it either -1, be it either negative or positive. For example, so if there was D here, right? If there was D here, okay. So here it would have been 1. Here it would have been 1, right? And there was no D character here. So at the end, the state of the array would have been this, wherein we would have 1 over here. So in this case, again, we would have written false. Or if this was the case, or if this was the case that there was no D, but D was here, right? D was here. So what we do, so whenever we iterate to the S2, right? So what becomes the D, what is the position of D here? So 99 minus, sorry, 100 minus, sorry, 100. The ASCII of D is 100 and ASCII of A is 97. So it comes out what? 3. So what we would have done when we are iterating through S2, we are decrementing the frequency. So in this case, it would have been -1 here. Okay. So in this case also, we would have written false basically. Okay. So this is the intuition behind solving the problem. I have tried to make it very easy for you. So I hope you have got the intuition. Okay, let's go and code. So before going to the code, I'll request you to please subscribe to the channel, like the video. Okay. So first I'll show the Java code followed by C++. C++, that's not much difference. Okay. So let's call it free array. Okay. New int 26. Okay. So by default, the elements, it is going to be 0. Okay. Now let's quickly iterate through the string 1, s1 dot to char array. Okay. And as I said, whatever is the character, we are going to deduct the ASCII of A. Okay. And we are going to increment the frequency. Okay. Similarly, once we have iterated s1, we'll iterate s2, and we are going to decrement the frequency. Okay. Decrement the frequency. Now it's simple. What we are going to do, we are going to iterate through the array frequency. Okay. Arr, and we're going to check here. If frequency is not equal to 0, okay, simply will return false. Okay, so that means that the strings are not an anagram. And finally, we are going to return true if all the frequency is 0. Okay, so I hope you've got the solution. So let's quickly see the time complexity as well. So it is going to be O of n because we are having only one follow. Okay, and space complexity also we can say it's O of 1 because we are taking constant space of only size 26, that which is constant, it's not variable. Okay, and that is why we can say the space complexity is O of 1. Okay, so let's submit it. Thanks for watching. I hope you've got the solution. Don't forget to subscribe to the channel, like the video. Okay, test cases are processed. Let's quickly see the C++ code. Here it is C++ code, not much difference. So here we have taken vector. I've already explained this part. This part also I've explained. Okay. So I'll attach the code in the comment section. Thanks for watching. Please subscribe to the channel, like the video. Have a happy, healthy, and a great day. Thank you so much.